All right, we're at 4. Should I have canceled class? Thumbs for canceling class versus not canceling. It's too late now, but should I have canceled class? I didn't want to come in this morning. That's that's the thing, right? Is I always feel like, okay, so my job is to make sure you guys learn good, right? But sometimes, you're not feeling it. So, like, students, you can decide not to come to class, nothing happens. But if I don't decide not to come to class, then no one learns. It is what it is. Well, I'm hoping Brandon shows up because he was going to present choosing integration methods. How are people's final projects going? Better. Anyone stalled? Okay. Good. Little stalled. Okay.
I finally put my code in place, so I should probably show it to you, debug it a little bit, because I'm still kind of stuck on like the writing portion of it.
Okay. Yeah, one of the best things about, what we'll talk about today is that we're going to generally talk about how to use these different integration techniques. And then we don't have anything for homework or for pair programming. So you can keep working on. Yeah, but I think on Wednesday we agreed that. Maybe I only did it in the chat. Did I only do it in the chat?
Yeah, I think Wednesday you were like
You were like iffy on.
Yeah, I looked through all the problems, and without us, going out and actually trying to do any of these other techniques like Romberg or some of these other integration methods, just didn't seem appropriate. Okay. So I'm going to pick the final presentation time. I was going to do Wednesday during our class time. People have conflicts with other finals. Okay. So, it's I think that's correct. Okay. I guess I'll just pause the recording until Brandon comes. So let's pull up the choosing integration methods, and then we'll do depending on the problem. Use a specific integration based on the information given to you. So there's 4 different types. The trapezoidal rule, it's trivial, it gives you a quick answer. It's easy to go. However, it's not too accurate, but it's good enough for this purpose. It utilizes equally spaced points with current integrated data and lattice stories, specifically like uniform time intervals with the limits. Good for coding behavior functions and related functions. Possibly the best choice when compared to Logan in terms of its simplicity. Simpson's rule, very similar to the French rule. However, it's a lot more accurate than the same number of times. And, but it relies on higher order approximation. Because of this, it's not exactly the best choice for forming the people. So things that aren't smooth. It's only good if you understand the nature of the integrate itself. Also uses complete space being same methodology, which is a little use accuracy, but at the top above the assumption group. It uses the minimum and giving error distance for the it does not work for wildly rare. Mathematically, negate functions, it's design functions. So it's best for smaller functions that you can interpret smaller or bigger. Same advantages as number integration with the small number of data points, but you still maintain accuracy estimates. Still have the same precision for forming data instruments. It's simple to program in comparison to other methods. It'll be potentially the most accurate distribution. However, unlike the previous methods used, it uses unequal space points and it also utilizes weights for errors. If your data requires the use of the equally spaced points, then this is probably not the best method to use.
And just to clarify one more thing there, for Gaussian quadrature, I mean, of course, we're not figuring out how to do it here, but just like we did with linear algebra before, there's really good programs that exist. So if you're curious how Gaussian quadrature works, I would recommend looking at that section and then just using the NumPy library for that one. Sorry, continue. Good. Any questions for Brandon? Okay, pretty straightforward, right? Okay. So you have seen two of those integration methods. They're not more sophisticated, right? Successive integrations like Brandon talked about, or unequal weightings and unequal points, sampling the function at relative locations is the only thing that's happening different there. But it's the same type of thought, which is some interval width multiplied by some height, and you add it all up, right? That's the end of the day. So I would love for you to focus today on finishing all of your homework and getting your project to a really good place. I hope that at this point you have started to think about your presentation. Do we want to go over any of the ways in which you'll be graded for your final project and or presentation? You want to see that again? Okay. All right, so that material is here. Just sign in really quick. All right. Wrong class. All right, here's your semester project. Okay, so the things that I want from you are demonstration of your mastery. Okay. And you'll see the implications for that when we talk about how it's going to be evaluated. I want you to think outside the box, ask questions of your own topic, technique, and results. This is all in the past, that's fine. You should have already selected a project. We should have talked about it, and I should have approved it. Right? Here's the layout for the project presentation. Plan for 7 minutes of speaking with a few minutes to answer questions. All of your material needs to be in slides, PowerPoints, or PDF. We won't be going through your code. You will not scroll through your code. You will not scroll through your code. Okay. Your presentation will be, here's this thing. Here's this other thing. Here's this thing. Here's this other thing, right? It's a presentation. Okay. So here's the ideal presentation layout. One slide for why you chose. I mean, you'll need a title, first one, right? Pick a name, put your title slide together. And then you'll have one slide to motivate why you chose the project, why it's interesting to you. One slide for why others could be interested in it. And that could be from the perspective of, here are the applications that might be usable. Here are the things that I think you might like from a computational perspective, right? So you'd be like, if you really liked Rangakata, I used it in this context, or I wanted to explore blank, right? Okay. Then you're going to have 3 to 5 slides for the project itself. This is not describing your code. It's certainly not taking screenshots of your code and adding them. Okay. What this is saying is, in order to do the project, I did X, Y, Z. And you can just say that, right? I did Rangakata and give the original equation, or, you know, whatever the differential equation you're trying to solve in its normal form, not in its coded form. That's the thing that you try to say. Here, I made a certain approximation. That's when you would talk about them, right? I had to assume that this was a 2D instead of a 3D. Or I had to assume that there was no interaction between the proton and the electron, right? Those are the types of things that you're talking about in those slides. And then your results. The first time I did it, it looked like this, and I realized that was right because blah, blah, blah. And then I made this modification, and it started to look like this, but I still knew that was right because of blah, right? 3 to 5 slides of results. And then you have a summary. Here's what I learned. Right? Here's how I knew it was right. Okay. And you're going to have some backup slides. And that's where you can add any extra things that you wanted. Right? Here's a little breakdown of how I did these things. Right? This section will be particularly important to you. Okay. Not all code needs to be yours, but all code needs to have credit where credit is due. So if you use ChatGPT to write a piece of code or to edit the code, or if you use a library in order to do the linear algebra, or if you borrowed code from a previous pair programming, identify that. This section, written by me. This section, not written by me. Yeah.
So when you're citing code from a different source, would that go in the end as like the works citing page, or would that
No, directly. In a comment, exactly where it appears. This routine taken from blank, right? These 5 lines written by blank. Does that make sense? Because there's a big difference between having an entire thing of code, which you're going to turn into me and I'm going to read, right? And I'm going to look at your pair programming and your homework and your final project. And if I don't see the same voice in all 3, you'll fail. Because your voice comes through when you write, right? Some of you don't like to use comments. Some of you use comments right away. Some of you write little sections. Some of you don't write little sections. Everything changes. Some of you write your variable names long. Some of you write your variable names short, right? All of these little stylistic choice show me who you sound like. I know what ChatGPT sounds like, okay? So if I see the whole code written by someone else, how can I give you credit for that? Does that make sense? Okay, but writing code is not the same as computational physics. So it's really important to remember that this is not a coding class in so much as it is a computational physics class. So what am I going to be asking for instead? Does your code contain an algorithm that will solve the problem? ChatGPT might give you that, right? Sometimes it doesn't. So just warn you. Does the code run? This will be the hardest part, right? Debugging, making sure that it works, making sure that you're getting the right answer. How do you get the right answer? How do you know it's correct, right? So there's 50% of your points right there in doing the debugging, making sure you got it right, making sure you fully understand it. And then Does it have good programming practices and extensive comments, right? Okay. So this is how I want you to get 100. For the slides themselves, I'll ask that 40% the slides directly address the material. What I mean by that is, that earlier part over there, do you have that same type of format? It doesn't have to be exactly that way. You might have 2 or 3 slides for motivation. That would be perfectly okay. I want to see that they demonstrate a mastery of your chosen topic. Okay. You're not going to give a lecture on this that you would present to hundreds of people, right? At some conference, but did you understand what you were doing, or were you just listening, right? Is there some sense of like, I felt like I was doing this on my own, right? Can you relate the material to the class itself? And what I mean by that in particular is when we say, okay, I took this equation here and I turned it into this piece of code, what would the word be there? Equation to the code. You're approximating that process. That's going to introduce what type of error? What's that? Not just human error. Obviously, human error we can barely ever get rid of because I'm still human. Last time I checked. Do we remember what the 4 types of error are? Approximation error. Yeah, that would be the appropriate one, right? Because we're taking a real derivative and we're approximating it in a finite difference method. So remembering all of these steps, and some of them you've internalized, right? But just remembering how you got there, right? So we had this conversation about, okay, this thing is going right over here, and it's breaking when I do this. So having that connection to understanding how the physics can break down because you've transported it to a computer shows the difference between whether or not you're just following along or you remember some of the material from the class as a whole, right? Okay. And then I will give you 10% if you ask questions of other students. So you have to be paying attention as you listen, and I'm going to write down the names of students who asked questions and not, what's your dog's favorite name? Right? Does that make sense? Okay. Meaningful, interesting questions. I want it to be a conversation. Okay. Problems, issues? Everyone happy? Okay. So those are my expectations for you. And we will do all of this 5:15 in class. So at some point, probably, well, I guess we could do it right now. Who wants to go first? Alfred. Who wants to go last? What? All right, we don't have to do both names. You don't want to go next? Okay. The third? Okay. Okay. All right. I go last? Okay. Okay. Sixth? You want to go seventh? Nice. Well, there's a few people who are missing, but okay, good, fine. So let me pause the recording there, stop